Hi, everyone. Let's wait a few more minutes, give everybody a chance to join in. Then we're going to get started.
Hello, everyone.
Was anybody saying something? Because I missed, my internet connection is not good.
I just said hello. Can everyone hear me? It doesn't seem I can get my
Yes,
camera on.
I can hear you. How are you doing, Rich?
I'm very well. Very well. Just busy in work at the minute. I can only stay for about half an hour because I've got another meeting.
Sounds good. Sounds
but
good.
you know, hopefully we can get through what we need to get through in a half an hour.
Sounds good. So I was able to try different strategies for outlier detection, and IQR strategy kind of like I was able to implement. But we can implement few other strategies, but it turned out pretty good. Means we were able to kind of like implement it, and we are not losing a lot of data based on the outlier detection. So that's a good thing.
Yeah, that's the thing. One of the interesting parts of a project like this is the further you get down the project into your EDA, into your feature selection, into your model building, you can always go back and rearrange the data pre-processing just to make sure, you know, because until you start building the model, it's difficult to sort of understand how it's got your model is going to work based on what you've done. So yeah, you'll be constantly going back and forth between the sections.
Yes, it is the same thing. Means I think somebody was talking in the chat, and I replied exactly the same thing. That we don't know whatever we are doing whether it would work for our model or not. So let's wait for our model and everything. Once we start building that, then we will know whether what kind of imputation would give us better results or things like that. Yeah.
Hey guys, yeah, it's most of a iterative process, as you said in the chat, and
yes.
So it's good that I'm glad that you guys give us so much lead, like so much the work. So I think will give us some buffer days to iterate, like, because I'm sure we will have to revise some of the things.
Yes, absolutely. Yeah.
So let's just wait for 2 more minutes. And I also encourage everyone to please show up on time, so at least we can finish our agenda on time. Let's just wait 2 more minutes and get started. Well, in the meanwhile, I think one thing I can cover, one of the participants suggested on the chat that I think her name was Anushka, about that project management, or like the thing about tasking. And this is why I was asked for that leadership role. I think we might need that, because even for me also, I have to go through all chat. I'm sure participants will be also keeping up. So I was hoping somebody has a one screen, they can see what the status are. What do you guys think on that? There's some stuff Omdina shared with me. I'm going to ask somebody of the participants if somebody can volunteer to be a project management lead. It shouldn't take too much of your toll on your time, but those leadership role really helps to get into that Omdina community as well, get the invitation of that as well. So please reach out to me either now or just message me privately. That would be a great help, I think, in our project. Since we are just started, definitely. I'm sure there'll be a lot in the end to keep up.
Yes. So if anybody does not volunteer, we are always here. So yes.
Well,
so we would recommend, we would recommend that anybody else volunteer, because everybody get the chance to kind of like play some kind of a lead role in some way. Yeah.
Yes, totally worth it. Well, I think we should get started. It's already 9:05.
Yep.
And since there's a lot to cover today, so I'm going to keep my agenda in the end. So I'll give you guys the chance to just get started now.
Yes. And one thing, Imran, I will have to leave at 9:55. So means if we can possibly sum it up by 9:55.
Yeah, definitely. I have some work commitments too. Yes. So let's just try to keep things.
I have to leave at past, just because I've got another meeting with work. So
how about both of you can try to get it done, or at least like by 9:35 or so?
Yeah.
So at least people can.
Yes. So can you let me share my screen, Imran?
Oh, sorry. Yes. Sure.
So okay, so we can get started. So since this is the final meeting for this particular task, I would be starting from the top, and I'm kind of like just keep it to this particular task. So we have done some extra things, for example, like something related to EDA, feature selection, model development. So we are trying to do whatever we can. But right now in today's task, we will be discussing just about the data pre-processing steps, that what we did, what we end up with, and what we are going to kind of like, what would be the output of this task and what we are going to do next. Sounds good? So as we know, all of majority of you have gone through the data, and we know what exactly we are dealing with, what kind of features we have, and what kind of
briefly, just 1 minute, just cover the data. There are some new participants, just as a 1 minute overview to the data as well, please. Sorry.
Sounds good. So what exactly we are doing is data overview is we are kind of like predicting what kind of energy consumption is happening in buildings across US in different states in US. So data has been collected for that, and we have around 86,000 observations. And train and test CSV files have already been uploaded in the project management folder, which you can find on Slack. And the features that we are dealing with, there are about 63 features in total. And those features cover something like this, that the building ID, then year factor, state factor, building class, what kind of a class category it is, facility type, or floor area, or so many different things. What are the average temperatures? What are the minimum and maximum temperatures, the wind speeds, so many different things. What we are predicting this particular variable, which is site energy usage intensity, which tells you how much energy has been used by that particular building in that particular year. So that is our goal. We want to predict or the energy usage based on the given features. So for data training part, what we did is we basically, there are some standard steps. We followed those standard steps, and we tried different strategies in those standard steps. We started with simple, just taking a look at the head and tail of the data. So we just called open the data using pandas. We'll take a look at it. And when you take a look at it, you can see that there are some values which are categorical. You can see there are strings over here. You can see some values are missing. There are NaN values over here. You can see some of the values are, there are a lot of zeros. That means days above. So we have to be careful and keep looking at different odd things in the data and get rid of those odd things or fix those odd things. So what we did is we basically take a look at both train and test data, then look at the shape of the data. You can see that our training set has around this many rows, 75,000. And it has about 64 columns. One of the column is our target column. So technically we have 63 features in total. And the test set, we have around 9.7 thousand rows. So we have good, very big data. That means when we are coming to the later stage, which I will talk about it. Then we take a look at what are the data types and how many null values in every single column we have, because we want to pinpoint certain columns that we want to deal with. So if we have good data in certain columns, that is good. But if some columns are not giving us good information, we need to kind of like fix it. So you can see that if so some of the variable types are object. These object means they have maybe multiple different types of data types. That's why we call it, they give it as an object, or maybe it is a string. So that means most probably they are categorical variables. Some of them are integers, some of them are float. The difference between is just the decimal places. If there are decimal places, those are floats. If there are no decimal places, those are integers. So we can take a look at it, and it gives you the summary at the end that how many float variables we have, 24, how many integer variables we have, 37, and how many object variable, 3. That means 3 categorical variables, not many. So we need to kind of like at the end do encoding for that. So next thing, let's calculate the number of null values. We figured out that these are the columns which were showing some null values. As you can see when we were going through it, this is the total number of data. All these columns are full data, but there are some features. For example, like if you see over here, there are missing values. So we need to fix that. So over here, you can see year built has about 2.4% values missing. Energy Star has 35, and so on. So this is the easiest one we can deal with, because this is about just 1,837 rows out of 75,000, which means if we can just get rid of those rows, that would because that would be more efficient and time saving, and make our model complex, and we would not lose a lot of variability this way. So which means getting rid of these rows would be handy, and we can fix one of the column very easily. But remaining other columns, there are 60%. First of all, we cannot just get rid of this particular column. We have to check whether it is correlated with the target variable or not. If it is highly correlated, that means we want to keep it and we want to fix it somehow. But if it has no correlation whatsoever, then we can get rid of it very easily, because 60% missing values, that means we have to come up with something really amazing to get it, or maybe make a complete model or complete data set for that, for prediction part, and we can do that, which is kind of like we would be doing most probably. Let's see what kind of encoding and what kind of imputation we could be doing. Now, I extracted kind of like the list of all the variables which had missing values. Then we visualize these values. So this visualization tells us very important details. You can see that over here, when you look at side by side, the values which are missing are kind of like at the same level, which means it is telling you maybe at that day, that particular instrument which is making sure, or what kind of errors can happen, means why the data is missing. We need to look at it, whether it is missing because of some technical issues, because of some other reasons. You can see if we research about these particular variables, they are all showing that the values are missing on the same days. That means for the same building. That means something went bad, or something was not right, or something was not working at that day for that particular building. So that's why data is missing. So which means we need to keep that in mind. So we need to look at those relationships as well. So this gives you a very good visual overview that which variables are kind of like showing you very similar patterns. So some of you talked about in the chat, in the Slack as well, that they have very high correlation. So yes, it looks like pretty that they are missing, the days are missing at the same day. That means there must be some sort of way to calculate these things. And if that one thing is missing, all the variables are showing missing values. So something like that. So it's a good understanding, good kind of like insight somebody got. So these are all notes. If anybody is looking at this particular notebook, you can just read the notes along with that, what we are kind of like getting insight from, or what exactly our understanding is. And if you want to add some understanding that we were not able to write here, feel free to write it, update it, and put it on GitHub, and that would be amazing. So for descriptive statistics, we kind of like just figured out the mean, standard deviation, minimum, maximum. So this gives you another idea. For example, like if you look, the standard deviation for year factor is not that big. That's reasonable, because if we don't have that many years of data, then that's totally fine. But if, for example, none of the variables are showing zero variance and zero standard deviation means only one value. That means we can get rid of that particular value very easily. But right now, none of the variables are showing something like that, which means we cannot get rid of, based on just this thing, any of the variables. But there are certain things we can look, for example, like over here, you can see direction, max wind speed. The minimum value is 1, the 25 percentile is 1, 50 percentile, 75 percentile, all of them are 1, which means there are very few values which are 360, maximum is 360, which means there must be very few values which are above 1, otherwise they are 1, which means we need to be kind of like aware of that, and we need to kind of like, when we go forward, do accordingly based on what particular column is exhibiting. We have to take certain steps based on that. Now, duplicate entries, we can find, we did not find any duplicate entries. We will check for it after imputation and everything again. But right now we don't have any duplicate. If there were any duplicates, we could have to just drop them. So unique values, we can find that every single column, they have how many number of unique values in them. So you can see it is telling you that there are a lot of unique values in several different columns. For example, the categorical columns, you can see some of the categorical columns, I believe state factor, building class was a categorical factor, which means there were only 2 categories here, and so many different things. So there were 3 categorical variables. We can look at how many variables are. One of the categorical variable was building type, and it had about 60 different. Just 1 minute. So I have a sensor in my room. If I don't move, the light turns off. So now visual data exploration, what we did is we kind of like just take a look at the distribution of every single column. So we can see every single column, the distribution looks something like this. So we kind of like just visually explored it. We will go deep down in for this particular thing in EDA part, but for just now, we just plotted it and just take a look at it. So I have already done this in SweetWiz as well, which I showed last time as well. SweetWiz kind of like tell you a lot of different things. Then we looked at the categorical variables as well, how the distribution is happening. You can see commercial and residential, how this distribution is happening. We have more commercial than residential. And then after that, we can see that the number of building types, this building type is taking up the huge part of the whole data. That means what we ended up with doing is we ended up kind of like making number of categories a bit smaller, which we will see later. So during imputation and everything, Rich was able to implement that. So for outlier detection, what we did is I kind of like put it up here. So I was trying to do certain different types of strategies. There are several different strategies. If the data is normally distributed, then you can simply use, for example, like you can just get rid of based on 3 standard deviation rule, that if your data is 3 standard deviation outside the away from the mean, you just drop it. So that is one way to do it. What I did is I basically based on doing IQR interquartile range. So interquartile range, when you plot a box plot basically gives you whiskers. So these whiskers basically are about 1.5 times the interquartile range. What is interquartile range? It is the third quarter and first quarter. When you find that particular distance, that is the interquartile range. So anything 1.5 times a plus and minus of it is what gives you the whisker. So we can drop the variables which are kind of like outside that particular 1.5 value. So that is what I did. So I developed a function which kind of like get rid of it and then plot it side by side with the original one. So for example, like if you look over here, okay, for example, like year factor, originally it was this, and after that it was this. There were no outliers. Then after that, you can see this is floor area. So original distribution was something like this, and this is the box and whisker plot. When I applied the outlier detection, I was able to drop a lot of values, and you can see the distribution became a bit more normal. So after that, you can see this next one year built. The similar stuff, we were not able to drop a lot of things because they were in that particular interquartile range. Similar to this thing, it had not a lot of variables, but this one you can see a lot of variables. It kind of like was able to drop. For some of them, it dropped a lot of values. For some of them, it did not drop a lot of values. So, which is a good thing. We don't know whether this particular kind of strategy would be good for our model or not, because what we can do is we can just replace because it is based on the imputation. When we will be imputing the data, what kind of imputation we are using, that kind of like fix the problem that we are getting here, or we can try maybe the 3 standard deviation rule as well to see whether which one works well. So right now I just did IQR, but later if need be, we can do the 3 standard deviation rule as well. Or there are several other strategies as well. Yes, Imran, you were saying something?
Yeah, I would be, well, maybe later, I think I would be interested to see, it will be helpful for all of us to see with 3 standard deviation and make a comparison.
Sounds
just
good.
For FI. Maybe
I was implementing it, but for today I was not able to do it.
No, that's understandable. Yes. Of course. I mean,
yes.
We all have to work collectively, but that'll be interesting for all of us for later on.
Yes. Means I would be trying definitely, and I would be sharing along with that. But today I was not able to do it.
No, that's.
But yes,
we have a whole month. Yes. I mean.
Yes. So that's why I wrote still working on it, and I just hit it. Yeah. So once we fix the outliers, now we have more missing values, because what I was doing, I was just kicking out those values. So now we have more. So now imputation would fix those things. So we tried several different imputation techniques. Rich tried KNN, and based on KNN, he got very good results. We don't know whether they would be good for the model or not, but they're amazing. Then he also tried another one, which is scikit-learn imputer, simple imputer. He tried that as well. And so we tried several different strategies. So at the end of this particular task, we would end up with kind of like a data which is pre-processed, no null values whatsoever. All the categorical variables are fixed. They have been encoded. So we will have a data which we can kind of like go and explore further. So that is technically the end goal of this particular task. So since we are trying different strategies, what I would be doing is we would be generating, since we are trying different strategies, every strategy, we would end up with a different data set. So I would be kind of like saving the CSV files for every single strategy separately, so that when we are making a model, we can just do them side by side, and we don't have to come back again and get the data for that particular thing all over again. So what I would be doing is, since we are doing different strategies, every strategy is ending up giving us a different data. That means we can just create different CSVs, and we can kind of like just keep them. And later when we are making model, we can just use separate all of the CSVs and see which one gives us better results. And then we can decide which one was the best strategy in this particular scenario. Okay, so he tried a simple imputer, and he converted all of the values. And finally, we checked for the missing values. At the end, we did not have any missing values. As you can see, everything was kind of like fixed. After that, we wanted to fix the encoding part. We wanted to fix the categorical variables. For encoding part, we had different categories. We come up with different ideas. And for facility type, there were 60 different values. So what we did is we basically put them together in different groups. So fixing state factor and building class was easy because there were not many unique values. So we can just simply encode them straight away using getDummy and drop first column. And for facility type, we have to come up with an idea. In last meeting, we come up with an idea that we should group them, because when you look at the distribution of the data, for example, like this, so there were 60 buildings, and one of the building was kind of like way huge, and all the other buildings were pretty small. So what we did is we kind of like put together different facility types into one category. So we ended up with 5 categories now. So now we can encode it very easily. We will have just 5 more columns added to it. Otherwise, we would have 60 columns. So that's kind of like what our strategy right now is. Later, if we see, because when I was doing some sort of an EDA, and I was looking at the test set as well. Right now, we haven't touched the test set. So when I was looking at the test set, I was looking at the distribution in the test set for those facility types. It is totally different. So there are more categories. So we need to kind of like take a look at that as well. And based on that, we can kind of like come up with the strategy that whatever we have more categories in the whole data, we can kind of like just stick to those categories. So we can kind of like work on that. And finally, one hot encoding, everything, we were able to do it. And that is the end of this first task. We were able to do several other stuff, but right now I'm not discussing because this is the end meeting for task 1. So let's keep it for task 1. Next, we will be doing exploratory data analysis. We will talk about it later, but right now, this is the end. And end result would be a pre-processed clean data with no missing values, no categorical values. That is what we are ending with. If anybody has any questions, anybody wants to add something, Rich, you wants to add something, or anybody, please feel free. I'm done with my presentation.
Yeah. Just to add, in terms of the last phase of the encoding, I also scaled the values as well. Now scaling brings down it's not as the effect isn't so negative when you're using a regression algorithm. The weightings of the variables don't count for as much in regression, but I think it's good practice to scale your variables and bring them all into a similar range of values. That makes the learning of the algorithm less biased towards heavier or larger values. So what I've done for the next stage of EDA, I haven't sort of left in the encoded values in the original training data set because it'll be more difficult to do the EDA. So that has been put down as a separate data frame, which we can then match up later on once we get to feature selection and model building and whatnot. So that's just a note there. As Salman said, it might be a good idea for everyone to save the data in a CSV at each step of the way, and then we'll be able to run through models and test them on the various different techniques that we've applied when we get to that point. But yeah, to sum up, I think what we've done so far for the initial sort of pre-processing stage, I think what we've done is quite effective. The true test will come when we start testing and building the model together, and that's when we can then go back and go, make amendments and adjustments when we see fit. But yeah, I'm very happy with where we've got as a team.
Definitely. Any questions, anyone, anywhere in these steps so far which is covered? Feel free to ask. There's nobody gonna judge you.
I have a doubt regarding the outlier detection and removal to Salman. Can you please explain that part again, the three standard deviation rule that you said?
Oh, yes.
Guys, I'm going to have to drop off. I've got to have to attend another meeting.
No worries,
I'll watch the recording. If anyone has any questions in the meantime, just hit me up on Slack. I'll be available in about an hour or so. But thanks very much, and thanks, Salman. That was a great presentation.
Thanks, Rich.
Yes.
Cheers.
Thank you, Rich.
See you soon.
Yeah. See you.
Bye-bye.
So yes, Rashmi, so I can talk more about it. So I would be putting some links on it. So I found a very good article on analytics Vidya, and which is kind of like about the complete outlier detection. So I have shared it in the repository, means in this notebook as well. So
Okay.
Let me open it. So what exactly it does is, if your data is normally distributed, okay, let's go and let's take a look. For example, let's look at a variable which shows normal distribution. So let's see, this is kind of like a bit normal, but I can make it normal by doing some standardized. It means it should be standardized data, not normalization. Normal distribution, but I want to make it standardized using the z-scores. So z-scores, what exactly it does is you take the mean of the whole data of that particular column and subtract every individual x value or your value of that column with the mean, and then divide it by the standard deviation. So you end up with a particular kind of like a z-score, and based on that z-score, you standardize your data. So what you end up with is your mean turns out to be now 0, and then it kind of like gives you a distribution, and how far away from mean you are, that is telling you the standard deviation. So if you are 1 standard deviation away, 2 standard deviation away, or 3 standard deviation away. So when we kind of like take a look at that, let me open that document. I think I have it here. This is a good diagram. You can see this center value is the mean value. Then this is 1 standard deviation. This is 2 and 3. So what I'm in this particular strategy, you would be doing is you would be standardizing your data, and then you would be dropping all the values which are on the right hand side of +3 sigma, means this standard deviation away, or on the left hand side, which is -3. So you will just drop those values. That would be the one strategy. So the IQR range, which I did, it uses the box plot and interquartile range because it uses the central tendency. It is not standardizing the data, but here we standardize the data. Yeah.
Okay. Thank you. Thank you so much.
I have a question. Like when we say like we have outliers and we are deleting or removing those particular points. So what does that mean? Are we removing those particular number of rows which contains outliers?
No, we are just removing that value in the column. We are not removing the row. We are just removing that value. So that value would be assumed as null value.
Okay. One more thing I couldn't understand, like somebody proposed in Slack, like there is a high correlation between wind direction of wind speed and mean and max temperature. Then she said like we cannot use KNN in the imputation in that case. So I couldn't understand if there is a high correlation between those two. So why we couldn't take KNN imputation into account?
Means this is something I have to go and read about myself, because that was a really good question. When we are doing EDA, I would be able to go in depth and read about those variables, because we need to understand what those variables are, and kind of like read some theory about it. And that would give us a good understanding whether the correlation is just random, or is it based on because of they are similar things. So this is something I need to read up on myself by myself, and then I would get back to you. But right now, I don't have a good answer for that.
Got it. Got it. Thank you.
I think Rich did that KNN part, so I think he has more kind of like work or kind of like hands-on experience on this data set right now. So I think when he will watch the video, or I would recommend you to put up a question on the Slack. He would get back to you, or I would get back to you when I read about it. Yeah.
I have a question on outliers thing. Someone?
Yes,
Pardon the interruption.
Sorry,
Sir,
1 minute.
continue to
Yeah.
Christopher Augustine to the main office, please.
Okay, so yeah. Can you say your question again?
Yeah. So when you said we use the box plot or IQR method, so it was done on all the numerical fields?
Yes, all the numerical ones.
Okay.
So because yes, categorical, we cannot do that. We have to kind of like encode it and then do something. But yes, it was done on all the numerical columns.
And also, maybe I missed it. What method was applied for encoding on the state variable? Because we had around 6 values. So did we also apply the similar?
We reduced. So we reduced. You are saying state variables?
Yeah, state variable. I think state 6. I think state 6 had the maximum 1 to 6, right?
Okay.
Yeah, this one.
Yes. Let's see. I think we did a simple imputer on that. Yeah.
The state factor.
Yes, state factor is simple imputation. Means, in fact, the KNN, once we tried it and we put it up. Wait a minute. We are talking about encoding, right?
Yeah, encoding.
Encoding or imputing?
No, encoding.
Sorry, my bad.
Because it's a categorical field.
Let's go to imputation. Yeah. Encoding. I think we did just a simple get dummies, simple one-hot encoding. One-hot encoding, what it does is it basically ends up giving you 6 columns if there were 6 categories, and we just dropped one of the column, because what those 6 columns do is basically it gives you 6 columns, and if the category 1 is present, you would have 1 in category number 1 column, and all the other columns would be 0. And if you drop one of it, that means if all of them are 0, that means it's automatic that the 6th one that we dropped, that should be this one.
So this one was done for building class because they had only 2 values, right? Pandas dummies. Yes. I'm asking about the state factor. What was done there?
We did the pandas dummy for that as well. Yes. So it is the same one-hot encoding. So we did that for these, and then one-hot encoding and PD get dummies are one and the same thing. They are exactly the same thing. Just one-hot encoding is from sklearn, and PD get dummies is from pandas. The only difference is that otherwise they do exactly the same stuff.
So in that case, did we the highest values were for state 6? So did we divide them between the 2 groups, like one is state 6 and other is rest of them? For the dummies, you need 1, 0, right? Or 6 columns.
Yes, we just created, because 6 columns, we can deal with that, but 60 columns is too much.
Yeah,
so,
I get it.
Yes.
Okay.
Anybody else has any questions?
Salman, there's somebody posted a question on chat.
Yes, for one-hot encoding.
Joshua, yes.
The preprocessing. Okay, so yes, Joshua, one-hot, for example. Yes, so Joshua, it's kind of like the machine learning models work in a way that they understand only mathematical language, only numbers. So if you put some strings in the data or in the model, in your data set, what it's going to do is it's going to give you an error. So machine learning machines only understand numbers. So we need to convert anything which is not a number into numbers. So encoding is kind of like that thing. So when we are encoding a particular variable, when we are saying that, what we are doing is we are converting, for example, the facility type. Or kind of like what kind of a residence. Wait a minute. Okay. So what happens is the categories, if we have just two categories, like means I'm not talking about this, I'm just giving, since you are asking as a beginner, I'm just giving you an example that would be easier to understand for you. So for example, like if we have a data set and we are kind of like, we have a column which is telling you that whether the person is a male or a female, right? So if my data set has male, M for male and F for female, and I put that in my model is going to give an error. I will convert it into a number. So one way to do it is I can convert male with 1 and female with 0, or the other way around. And that way I can just convert that string into a number. And this way my model would be able to understand. And when it is using 1, that means it is a male. When it is using 0 for that particular variable, it would understand it is a female. So the purpose for encoding is this: we want to make it or translate it in such a way that machine can understand. Does that answer your question?
Salman, I'm sorry to ask you to repeat, but I kind of
Sure.
got lost what one hot encoder is.
Oh, one hot encoding. Okay, what I can do is I can just quickly show you. Or in fact, I think we have done it here. So let's go here. So for example, over here, we looked at facility type. Let me give you this idea. So you see, what we did is building class residential and things like that. So if you look at the end of the column, there's a new column generated, right? So this new column is telling you 1. When it is 1, that means it is a commercial type. And when it is 0, it would be residential type. So what we did is originally the building and residential type column had these values, whether it is building and residential. I think we have dropped it, but let's see here. Let's go to the top because the original one has it. Okay, you can see that this building class has commercial value or a residential value. So Imran, can you let me share my screen, please? Okay, so what I was saying is, for example, if you look at the beginning here, this is our initial data set. You can see the building class has either commercial or residential written in that column. So one hot encoding, what it does is it basically breaks it down into how many categories you have. I have 2 categories, so it will break it down into 2 columns. The first column, if it is residential, the first column, I would just, one it would be residential, one would be commercial. So if it is residential, for example, in this column, it's going to put 1 in the residential column and 0 in the other one. And if it is commercial, then it's going to do the other way around. So it will create 2 columns out of 1 column and convert them into either 1 and 0. So it's kind of like converting it into binary numbers, 1, 0. So if we have 6 columns or 6 categories in a variable, it will create 6 columns. And it will only put 1 in the column, which is the value at that particular row in that particular column. So does that make sense?
Got it.
Or otherwise?
Got it.
Okay.
It's like the example of male and female. It's just that it may be
Absolutely.
any number of values. Got it. Thank you.
Yes.
Somebody has a question on the chat.
So why have not we labeled encoding for the feature having 60? Roshni, that's a good question. But the thing is, we have 86,000 values in total, rows in total. We have 60 variables in total. And if we create 60 more features, that means if I encode, label encode, okay, sorry, my bad. You're talking about label encoding.
I'm just trying to
Label encoding.
understand when to use label encoding and when to use hot encoding. Like,
So label encoding, what it does is basically assign a number to every single label in the same column. It does not create 60. So we can try it, but keep one thing in mind when machine learning model. So if it assigned number 60 to one of the column, one of the category, and number 70 or number 600 to other one, which means when you're putting that number in the machine learning model is giving more weightage to that 600 value as compared to 60. So we don't know which one has what kind of a strength in kind of like predicting the answers. So when you have 60 variables, label encoding would assign different labels. If you assign something 1, but it had more weightage than as compared to the one which is 60, then machine learning model would not understand it. So yes, we can try it if you have less number of variables or something. That is recommended. Means for if it is male or female, we can do it. Or for example, if we had 2 categories, we can do it for that, and that would be fine. Technically, that is what we did, because when you are doing one hot encoding and dropping first column, technically that is what you did. You either have 1 and 0, so it is kind of like a label encoding. So we can do that, but machine learning model would give weightage to values which got the higher label number assigned to them, as compared to the ones which is low number. So this is something we need to always keep in mind. Yeah.
so the preferred way is always 1. If the number of values in a column is more, it's preferable to 1 hot encoding.
If you're dealing with means depending on what kind of a data you're dealing with.
Okay.
So in some data, and for some data, label is simple. One hot encoding is kind of like it creates complexity in the model. So label would not create complexity, but it can give you a wrong model or different, not an accurate model. So we need to kind of like keep a check on both things. So yes, we don't want to make our model complex, because if we keep on making model complex, yes, it will understand the data better, but it will take more processing power, more kind of like computation power. That means more costly.
Okay, got it. Thank you.
Salman, with this explanation, this label encoding can still be applied on the state factor because they are just 6 unique values. Will it be advisable?
So
yes, we can do that. Yes, Michael,
you can't use, so label encoding should not be used in any situation in which the category that you are labeling is nominal data as opposed to ordinal data. So we can't use it on state. We can't use it on year, because essentially label encoding builds into it like a hierarchy, because you have like the labels 1 through 6. If you put that into a model, it's going to, the model will automatically bake in that a bigger number has some additional meaning. So you can really only encode something with a label encoder in which you would have, I apologize for my cat. You can really only encode something with a label encoder where that type of relationship is present. So like you could, like if you had a category which was like a bunch of a feature which was like the place someone came in a race, like first, second, third, fourth, you could label encode that, but you can't label encode something like facility type, because when you would do that, it would, or state factor, it would build in this hierarchy which it doesn't exist. Essentially, the model would derive additional meaning from the data where meaning doesn't exist. So that's kind of the difference. I linked in the chat. I linked a kind of explanation of when to use a label versus a one hot encoding thing, which it's a pretty good read on why those things are the way that they are and how they both work. So
Yep,
Thanks, Michael, for the
that's great.
Makes sense.
Yeah. So that is I think means that was kind of like put up in a very good words, Michael. Thank you so much. So anybody has any other questions? If that answers the question, that's good. But I think the link that Michael shared, let's check it out. And if you have any other confusion, still have confusion or something, feel free to just put the message in the Slack, and we would get back to you. Yeah.
Yeah, thank you.
Any other questions, anyone? Any other ideas? Any other suggestions?
Any other question, anyone? One thing I was hoping to suggest, maybe it might help to the people. There's a very popular book in industry. It's like I don't know, hands-on machine learning with scikit-learn, Keras, and TensorFlow by published by O'Reilly. I'm going to share the PDF copy of that. There's only chapter 2, which covers end-to-end of ML, which we are covering in this entire month. So those of you who are beginners, for beginners as well as for intermediate level people as well, that will cover in every details which most of us we discussed today. It will really help you tremendously. And the project which we are doing and they are doing in chapter 2 is quite similar to this which we are doing. They are working on a housing data set. We are working on this energy related. So I highly suggest you guys to take a look at that as well. I'm going to share that. And yeah.
And one more. If you guys check out Jason Brownlee's blog, he has an amazing blog. His name is Jason Brownlee. So he has created a lot of books, and everything that is in the books is on his blog as well. So you can find everything. So he covers everything on it. So just go check him out. The link is machinelearningmastery.com. So check out his blog, search about anything, you would get the answer for that. Means he would show you coded examples for it. Yeah.
Sweet. Do you mind sharing on our chat as well? I'm sure the other participants.
Yes. Yes, I would share.
Thanks. And any other question, anyone? Otherwise, I highly suggest everyone, especially those who are new, the stuff which our task leads have posted on GitHub. Please start your own Colab and literally type every code down and do step by step. So that will really help you to understand what's going on and help you ask better questions as well. And there's one announcement. Our one participant named Bilia Kiribo, she has stepped up to ask for be a marketing lead for our marketing site. So please help support her in terms of probably might be reaching out to you guys. I like our Facebook. We have a LinkedIn page, so please follow our page over there and help her out to promote our chapter as well. And Komal also inquired about being a project management. I'll share details, and she might be our project management lead. There were some concerns in the chat about there's difficulty in understanding what's the status of the task and where are we standing. So I think that having a project management lead will be a great help as well. So thanks a lot to both of you. And that's pretty much it from my side. Any other question, anyone? Otherwise, we're gonna just wrap up this meeting.
I did have one quick question.
Please.
I was looking at the test
sir.
data, which is something that we're not quite ready for yet, but we will eventually be using. I'm used to testing data having the target variable included, and then we would remove it prior to running it through the model, through the predictor.
Mm-hmm.
But I don't see the target variable there. So how would we validate whether our test is accurate or not with that test data? Like, I don't see site energy intensity usage.
So if that is the case, then we would just, since we have around 75,000 data, if that EU ID is missing, we can just split it using our train set.
Okay, I didn't know if there was maybe like another. I didn't know if the data was maybe in a different location, then I just wasn't seeing it.
So I believe this data is from Kaggle. So they took out that column, I think, for that testing purposes. Means they wanted you to submit based on this particular data and check on their end. So I think that's why that column is missing, I believe.
And there's no way that we can get that data from them in any way, or is
means I don't think we have any way to get it because Kaggle have it, and they don't display it, which means we can still split our 75. Means we can just
we'll turn our test data. Yeah, we'll train test split our test our training data into that. Okay, that was just what I was looking at. I was just confused when I was looking at the test data. I didn't know if maybe I was missing something, or because I was like, it's going to make verifying the eventual efficacy difficult on the if we ever decide to use the test data. So it looks like we probably will not be. Okay.
Yep, that's right. That's a good pick. Means I did not notice that. I did not take a look at the test data set yet.
One thing I'm concerned, like as far as people have brought up some concern related to test data, my concern is, let's say if we get to 2.5 weeks or so, and then we find out, oh, test data also needs work. Because, and from this guy, when I was reading this chapter from this book, what he did, he literally take care of the test data also initially beforehand. And so I guess that's partly the reason why. Well, we will find out, I guess we'll learn.
I mean, so like when all of the manipulations we're doing on the training data will eventually have to be done on the test data as well. So, which is why I was looking at it, was I wanted to see what I started doing some light EDA on the test data to see how closely it matches our training data. And I was trying to, I just didn't see the site EUI, which is what we're supposed to be targeting. But if we don't have it, I don't know that we can even use the test data to begin with. So we may need to split what we have for training, or I think we'll have to.
Yes.
But
yes, we will have to. Yeah.
That's a good point. Actually, we need to think about it more. Any other question, anyone? Okay, then if that's the case, I think we should just wrap up our today's recording. There are a few things to ponder upon. There was a good analysis. Thanks a lot, Salman, and thanks to Rich as well for covering all that stuff. There's some stuff we all need to collectively pitch in efforts like that testing data thing and some other challenge, maybe testing out those 3 standard deviation, or maybe putting more value within our data pre-processing to make it more comprehensive. So it's good that we all think and let's keep adding value from our end.
Yes, that's right.
Okay, guys, and have a very good day, everyone. See you guys on Sunday.
Have a good one. Bye-bye.
Take care. Bye-bye.
Thank you so much.
Imran, are we meeting on Friday again for the next test?
Only our regular meetings will be on Wednesday and Sundays only. That's it.
Okay.
9 till 10 a.m. Eastern time. Okay.
Yeah, thank you.
Thank you.